In this project, I focused on the growing field of supply chain analytics, which is expected to double in size by 2024. Supply chain organizations are increasingly realizing the benefits of predicting future events with confidence. The aim here was to predict supply chain shipping prices based on available dataset factors. So my approach followed the basic steps. First, I performed EDA in Jupyter Notebook. Here I have imported the necessary libraries that are required for our model training. Then I have imported a data set. I checked the rows and columns. What are the columns here that is dependent on our supply chain shipping prices. Then I have checked for then I have dropped all the columns that are not required for the model training. I checked for null values. There are many null values in the data set, and I checked the data type of all the columns in the data set. Then I the columns that has um, date time feature uh, that was not converted to date time format, so I converted that so that our EDA will be easy for us. Then I had here checked for null values. There are many null values in the data set. I've performed univariate analysis for numerical features. I used multiple graphs to analyze the shipping prices properly. Then here I have checked for the countries that have maximum number of orders with most line item value, and performing this analysis will help me to check the pricing strategy. Then performed data pre-processing. Here I have checked for data correlation so that if I could do some feature engineering, so I can remove one column either, or I can add something. Then here I have checked for the outliers, but I will not remove the outliers. There are many outliers, but I will not remove them because they will help me for the model training. Then here I have used some data pre-processing techniques. Yeah, then this is the class for numerical imputation, and this is the class for categorical imputation. I have filled all the missing values with using this class. This helped me a lot to save my time. Whenever I will do a next any project, I will use this same code to do uh, this type of project, so that my time will save. Then uh, after imputation, I have checked for the imputation and transformation. I've checked for the graph distribution. Then I trained the model, made a pipeline, then trained the model, and here it is. And I got the R2 score as 72%. Then my approach followed standard machine learning steps, uh, starting with data exploration, where I closely studied the data. I then cleaned the data to remove any errors, perform feature engineering to select the most relevant information, and built machine learning models for prediction. Here is my code. Here actually I have tried to perform an end-to-end machine learning program like industries does to train their model. I have inspired by them and did this project to create an end-to-end machine learning regression training pipeline. I handle tasks such as getting data from database, validating and transferring it, training models, evaluating them on new data, and deploying the best performing model. I experimented with various machine learning algorithms, including KNN regression, decision tree regression, random forest regression, a Darbost regression, XGB regression, and a voting regressor to find the best fit for our prediction task. To assess model performance, I used the R2 score, a metric that measures how well the model predicts the variation in the data. The main goal was to provide accurate predictions for supply chain shipping prices, enabling organizations to better manage costs and service levels in a rapidly evolving market.